Hello everyone. I am Albiona and welcome to the zkSync Connect Day, zkSync team and our guest speakers. With me today is Samee from Atlas.
Yes, thank you for having me, Albi. I'm Samee. I'm the founder of Atlas, and I'm going to be going over the fastest way to build on zkSync today. So you may be wondering, what is Atlas? So Atlas is the first smart contract editor that makes it possible to build dApps in minutes. We like to say we're the fastest way to build on Ethereum, but I'll let you guys be the judge of that today in the demo. So you might be wondering, why do we even need this? Well, chains like zkSync spend millions every year trying to get developers. I'm sure the DevRel team can tell you guys about that. And why is this happening? They try a couple of things. They try hackathons, they try content marketing, they try grants, incubating teams, outbound BD to find new use cases for blockchain development. But in my opinion, like the core problem here is really that it's just too hard to build in blockchain still. There's like a really steep learning curve. Even if you're a Web 2 engineer and you know how to build things, it still takes you weeks, if not months, to get ramped up. You have to use 10 different tools if you want to learn and actually be a production grade developer and build a protocol that has meaningful value. And it's really high risk. So if you build something and you get hacked, then you're going to lose all your users' funds. So it's kind of the holy trinity of terrible things you would want for trying to get more developers. So what if there was something that there was no setup, you had all the tools you needed in one place, you didn't have to use 10 different tools. You could open any repository in a click to quickly get started, and you can deploy to our favorite chain, zkSync, in just a click. So I'm obviously going to head over to Atlas. This is all what Atlas does. And we actually launched 5 months ago. This is a chart of our user growth on just developers in general. We already have more than 11,000 developers on Atlas, which is pretty cool. And from zkSync, we have now more than 3,700 contracts that have been deployed to mainnet, and over 7,800 contracts that have been deployed to zkSync testnet. So those are great numbers. zkSync is one of our top chains, so we're excited to be here and show you guys how you can be building bigger dApps on zkSync. So enough talk. Let's actually jump into it and build some stuff. So I'm going to come over here to Atlas. So this is Atlas. It's basically an IDE. You can write whatever you want in here. So this is, for those who don't know Solidity, this is like the most simple hello world contract you can have. And you can start being a blockchain developer by just clicking this button right here, deploy. And you've now deployed your first smart contract. So it's really that easy. So it's pretty cool. And you can even interact with this contract too now. You can do things like call this function increment, and you can see the contract state is changing in real time. So that's pretty cool. So let's see what it looks like to actually deploy this to a real network. We can come over here. There's a bunch of chains we can deploy to. I'm going to pick zkSync. And again, all I have to do to deploy and verify the contract is I just press this one button and I sign a transaction. So this is basically deploying it. We automatically verify this contract for you on the zkSync Block Explorer as well. And the same thing exists here, where now we can actually call this increment function. And instead of running on like a local blockchain, it's going to run on the real testnet. So I'm signing a transaction and we'll see the contract update. And we can see basically over here, great, this increment function just got called, and here's the contract that got automatically verified for us. So that's all pretty cool. This is like very basic hello world. How do you get started? You can see like in less than a minute, you already have kind of done your hello world on zkSync. So now let's start building something more advanced. So let's say I want to make maybe a token, right? So I can actually use our built-in copilot right here. I can say like, hey, write me a silly token. And it's going to generate some code for us. The cool thing about this is that it has context of Solidity. So you can ask it questions like, hey, how do I do this thing in Solidity? What is this code doing? I can go back and forth with it if I want. I can say like, hey, add this function to my contract, or explain what the vulnerabilities are. Great, so we got this very silly token. We can add stuff to it, but for now we can just create this file. And again, deploying this is very simple. I can just click deploy, and we're going to deploy this to the zkSync testnet. Cool, so we signed this. This is going to get deployed in a second. But you might be thinking, like, okay, if I'm building something advanced, then here we go. We can see the contract state, all the functions we would get from ERC20, all this, and then this import is all handled behind the scenes for you. So that was pretty cool. You have to remember, we basically launched a token right now on zkSync. I came to you here with nothing done. I just went to a website and we launched a token on zkSync, and it works in like a minute. So that's pretty cool. But if you're building something more advanced, you might want something like a test, for example. So we can actually also ask the AI to help us out with that. We can say like, hey, can you write me a test for this? And we have Foundry built into Atlas. So the entire Foundry testing suite, whether it's you want to fork a chain or you want to simulate a user transaction or whatever you want to do, is all built into Atlas. And you can, again, like ask it to generate tests for you or ask it to help write tests as you're developing, which is pretty cool. And that's pretty powerful because you now have anything you want to build, you can have the AI explain to you how to build it. You can have it generate code for you, and then you can also have it help you write your test to make sure that your code is secure. So here we have a generated test. I'm going to create this file, and then we can run this test. We just hit deploy test. This is just showing off like, hey, what can you do? You can import Forge, you can set up your standard test with whatever initiation conditions you want, and you can run them. So let's go over to like a more advanced test in a second. But before we do that, so what have we done so far? We've created a contract, we've created a test, and we've deployed these things to a real network. But this is only half the equation of if you want to build a dApp. So you still need to make a dApp front end that actually talks to your smart contracts on the chain. So for that, we also have a command line tool. It's pretty cool. It's called create Atlas dApp. And so you can use it by running this command, npx create Atlas dApp. And then for our chain, we're going to do --zkSync. And this actually will pull in all of your contracts that you've written on Atlas, and will automatically generate a front end for you that has the hooks that call the contract. So this is the project I'm just in right now, zkSync demo. So I'm going to click this. We're just going to change into this directory. And this is the most exciting part. We have to run yarn install. But basically, well, as I was saying, so this is going to generate a front end for you. It uses WAGME behind the scenes to generate the hooks for you, and it pulls in all your contracts. So however many contracts you deploy, they're all going to show up, and we'll see in a second. And it's really powerful because now the iteration loop for me developing a dApp is much, much faster. So imagine you're at a hackathon or you're building something with friends. Came here with nothing. I deployed multiple contracts to zkSync mainnet, or sorry, zkSync testnet. We tested them out, and then now I'm actually generating a front end for it as well. So you can imagine how this like speeds up your iteration loop quite a bit. And then if I make any changes to the contracts in Atlas, I can resync them and generate a new front end, which is pretty cool. So this might take like a minute or two. So in the meantime, I'm going to show you guys a slightly more advanced project, what it looks like. So we can come over here. I'm going to come over to this little DEX project. So this was basically me writing like Uniswap-like DEX in just one contract. So this is, we can go through the code if you want, but it's basically just like, imagine you had Uniswap and it was just a single contract where you had like swap, create, pool, remove liquidity, add liquidity, these things. And so we have this, we don't have any gas limit or anything in the browser. It's pretty complex. And then we can see what does a more complex test case with Foundry look like built into Atlas. So we're doing things here like, for example, pranking as specific users. And because I was setting up tests for checking liquidity providers and doing swaps. And so all of this basically is built into the browser. And so that's, again, really powerful because I don't have to know anything about blockchain development or my environment. I can come here with literally zero setup, and this just works out of the box. So this is still installing, very exciting. Okay, amazing. It is now ready to go. All right, so let's go over to this localhost 3000. So here we have the generated front end that we got. We can see the two contracts that I deployed to zkSync, Hello World and Silly Token. And so all these functions here are the actual functions that we can call on the smart contract. And you notice if I call a function like total supply on the Silly Token, this is the value that I actually put in when I deployed the contract. And I can do the same thing with all these values. I can do this, hi. If I hit write, it's going to ask me to sign a transaction because it's an actual smart contract write. And so this is now, again, this was fully generated for us. We wrote the contract in Atlas, we deployed it, and then we pulled this in here. And now if I'm writing my front end, all the functions to get the state of the contract as well as call the functions on the contract are literally in the code base automatically generated for us. And we also have like the connect vault button and all these things built in so that if I'm building a dApp, this is made much, much easier. So this is kind of an example of like how we can speed up this development loop. And you can have as many contracts as you want here. So this is like this token one, this is Hello World. If I had 10 more contracts, they would all show up with all the appropriate functions and what I need to call them. So I'm going to actually come over here now back to the command line. And we can open up this directory in VS Code. And we can see what does the generated code look like for us and what does it look like to customize that code. So if we come over to the source directory in this components, generated components, these are the, right here, hello world and silly token. So however many contracts that you deploy, they're all going to show up here under generated components. And if we click into any of these, let's just go into hello world, we can see these are the functions that exist on the contract. So I'm just going to click on increment, and this will open up the actual component that's generated for us. And right here is the hook that we need to actually call the contract. This is literally all you need. And then this is generated for you for every single function that's on the contract. And so that UI that I showed you before with all the inputs and the buttons, you can use that if you want, or you can just use this hook to call the function, read it, and do whatever you want. So that's basically the kind of the main core loop of Atlas. So I showed you guys, we came here, we deployed a bunch of different contracts to zkSync. Then we came to the create Atlas dApp. You were able to see your contract that you deployed. Oh, sorry, I killed the server. But you were able to see the contracts that you deployed. You were able to see the functions that were generated for them. We opened up the code. You were able to customize that code or call the functions yourself. And then you also have like a very advanced testing suite built into Atlas that you can leverage. And so to wrap this up, one more advanced use case that zkSync has been very excited about is account abstraction wallets. So we can go over to their docs, and I'm going to show you how you can actually run entire examples of GitHub repos directly from Atlas. So if we come to zkSync's building docs, I'm going to come over here to the tutorials. Let's do a daily spending limit account. So this is basically a account abstraction wallet tutorial that has a hard cap of the amount that can be spent on it in a single day. And so we can go through all of this if we want, or we can just click this button right here to open the entire project in Atlas. And we can call it whatever we want. And basically it's going to pull in all of the code from this GitHub repo. So that includes the deploy scripts to deploy the multiple contracts, as well as the contracts themselves. And we can actually, again, use this in combination with the other tools I've showed you earlier. So if we wanted to make an account abstraction dApp for a hackathon, for example, I could pull in this starter kit from zkSync, customize it however I wanted, maybe ask the AI to help me customize it, write some tests, deploy it, and then generate all the front end for me and use the contracts as well. So this is just compiling right here. We have to compile it before we can deploy to zkSync, but this has a couple of contracts I'll show you, as well as like deploy scripts to deploy the contracts and call these functions on it. Cool, so this compiled, we can see here an example deploy script. So we have this deploy factory account, which is basically a script to deploy this account factory. We have a spend limit contract, which defines what is the actual spend limit that we want for the account. This is the account wallet using zkSync's native account abstraction. And so I'm just going to run this script. We can go through this in more detail if anyone's interested, but we run this, we sign a couple of transactions, and it'll basically deploy my smart contract wallet, and it'll send some test transactions to make sure that is it actually enforcing the rules that I want it to enforce. So is it setting the cap for the amount that I can spend in a day? Cool, so we can see all of the logs happening. We deployed, here's the account address, we're funding the wallet, we're setting the limit for the account, and then we're attempting to send. And this failed if you go above this amount, and it retries with the lower amount. Cool, so yeah, that's basically all I wanted to show you guys. Again, basically we went through the entire loop. I came to you with nothing on the screen, and then I showed you how to deploy a couple of contracts really quickly with Atlas, automatically verify them, use the AI to help you out, generate tests, pull in template, create a dApp, all those cool things. So yeah, happy to talk about any questions for you guys, but overall, I think it's a pretty cool tool to use if you want to build a dApp on zkSync. And if there was anything throughout the presentation that you thought could have been faster, let me know, or you can just scream right now and we can talk about it. But yeah, we can consider it user feedback. But thank you guys.
Do we have any questions for Samee?
Yeah, do you support forks like archive nodes and simulating transactions for debugging?
For debugging, any debugging you want to do right now, you have to unfortunately do with like console statements within Forge Test Suite. But we're planning on adding a built-in debugger very soon. But people typically, if they're for what they do with us, is that they fork a chain and then they just use a bunch of print statements because it has like forged print statements right now. So yeah, that's the current state. But very soon we'll have a more advanced debugger with like opcode step-throughs. That's a great question.
Samee, can you repeat the question so we can get it on mic?
Oh yeah, the question was, right now we support Next. Are we doing other front-end frameworks for contract generation, basically? Right now, no. We're just doing Next, and maybe we'll do vanilla React, but that's kind of like what we found most people are using. If there's demand for it, then we would definitely think about supporting it. But so far, it's most people that have been building hackathons use either just Next or React. Sorry? Do we deploy only on zkSync? Oh, no, so you can deploy on any chain that you want, any EVM chain, but we're at a zkSync event, so I'm only going to deploy on zkSync. Oh, yes, you can. Basically, anything that is in MetaMask, we just use MetaMask to deploy. So you can sign a transaction, you can add your own custom network, but we will not automatically verify your contract if you add like some other random RPC. But anything in this list will get automatically verified for you on the associated block explorer. Yeah, that's a great question. So the question was, zkSync is like EVM plus. They have some more things that are not on all the standard EVM chains. So do we support that? The answer is yes, kind of. So if you're writing any contract, the contract logic is supported because we're using like zkSync's compiler behind the scenes. If you're writing a test in Foundry, then you're going to have some trouble because right now there's not 100% compatibility between Foundry and zkSync's testing suite. I think Nick is cringing right now in front of me because he's working on this problem. So we're working with the zkSync team very closely to get one-to-one compatibility both on the testing suite as well as like running the tests or contracts actually on a zkSync node rather than just like any EVM flavor. But that all being said, anything you write that runs on zkSync will work if you write it in a contract here and hit deploy. It's just you might be a little bit limited on the testing/simulation functionality, but we're very quickly fixing that with the zkSync team.
Any more questions? Yeah.
Yeah, great question. So the question is, should I use AI to generate all my code and make millions of dollars with my DeFi protocols? I would strongly suggest do not trust this thing fully. What I showed you this project earlier, so this is the one we were working on, zkSync demo. So we can come back here. So if we look at what contract was generated here for this silly token, this is an example of like very, very low risk contract because it's basically pulling in known packages like OpenZeppelin that are very battle tested. And so if you ask to do simple things, it'll very often do this. It'll basically very often say like, hey, yes, you can use this battle tested thing to write a token or NFT or whatever you want. Once you start getting into more complex things, so I showed you the project before of like, hey, I built this kind of simple DEX. If you ask it to build the DEX for you, it's much better at giving you an outline of the things you would need rather than giving you like spitting out the entire contract. And so empirically, what I've noticed is the bigger the project, it's better to go back and forth with it and kind of use it as like a sanity check to say, hey, what are the possible vulnerabilities here? Hey, can you outline what functions are important if I'm trying to build this thing? Or can you generate this one function for me? And then if you're building something small, it can actually basically write it completely for you, like this token. But in general, I would advise to use this as a tool to help you, a blockchain developer, be more efficient and so you don't have to remember or write boilerplate, things like this. I would not advise it to help like write your entire protocol from scratch. That being said, like many people on our app do that, and I'm sure some of the things have bugs in them. So maybe you guys should just look for AI-generated contracts from Atlas, and then you can potentially make some money like that. But if I were you guys, I would use it as a thought partner / to generate boilerplate code. It's really good for that. It's really good for Solidity syntax. Really good for helping find vulnerabilities. But use it as like a partner to help you become more productive rather than trusting this fully. You should definitely understand what all of your like Solidity code is doing. This is just in generally true if you're a blockchain developer. I think there's a couple tools people use right now to write smart contracts. I would say the big ones are Remix is obviously big, Hardhat is big, Foundry is big. ThirdWeb is big, but they're more of like a template solution. Like people don't really write contracts in there. So I don't consider them that. Like I kind of think of it as like there's a spectrum of like easy to use versus hard to use and like power versus weak. And so there's tools that are easy to use but not very powerful. So I would put like Remix and ThirdWeb in that bucket, where it's like good for templates, or Remix is good for if you're doing simple contracts. But once you start wanting to write more advanced tests, or you want to write scripts that link multiple contracts together, things like this, then you kind of start running into trouble. But for very beginner users, it's very good. And then you have things that are more advanced but hard to use, like Foundry and Hardhat. And my experience with those is like they're just very, very high friction, and they take a lot of time to learn. And they also don't even have all the things you want built in. Like it still is a headache to do a lot of things like contract verification or simulate forking chains or things like this. So we kind of just tried to combine the best of those two worlds, where can we make it easy for a new developer to use, which I think most of you guys would agree, like we came here with nothing, we press a button and we deploy. So it's pretty easy for a new developer to use. But then once you actually take that next step and say, okay, I'm not a noob developer now, I want to build like a real protocol. Can I have all the functionality that I'm used to, like advanced testing, scripting, these kind of things? And so we have all that stuff built in as well. So the goal is basically combine those two worlds, make it easy to get started, and then also make it a really deep experience if I'm a pro developer, so that I don't want to leave or go anywhere else.
So you're walking through smart contract development in the browser, and then you hopped over to your terminal for front-end development. Is there any plan to sort of combine the two and just also have the front-end development be in the browser?
Right.
So it's just all in one place?
Yeah. So the question was, hey, we wrote some smart contracts in the browser, but then I went to the terminal and VS Code for front-end. So should we combine the two into one? I tend to say no. The reason is because the front-end and JavaScript ecosystem is like very, very well developed. I don't think there's like that much of a gap there. I kind of think there's like, in the Web 2 world, there's two stacks that exist, right? There's like the front-end stack if I'm building an app, and there's a back-end stack. And I think what's going to happen now in the future world is there's going to be a third stack, which is like every company has a blockchain engineering team. There's like some protocol that interacts with my company. And so every engineering team is basically going to have a front-end team, back-end team, and like a blockchain team. And so my view is each of those should have its own stack, right? Maybe I use Vercel and Next and everything for my front end. I use AWS and Kubernetes or whatever for my orchestrate my back end. And then I have Atlas as like my blockchain stack, where I can deploy contracts, monitor them, monitor the security, all these things. So that's kind of how I view it. I feel like it's like a whole rat's nest to go into front-end development, and I feel like we don't have a unique advantage there. And like, I want you as a front-end developer to use the tools you're accustomed to there, versus we're focused on like, let's make the blockchain experience very magical.
May I ask another question? So when we're deploying contracts, we deal with private keys, and when we store it locally, it's okay because it's on our laptop. But when we want to deploy it using some web IDE, we know how our private keys are managed. So where do we store private keys, and how can I use my private key to deploy a contract?
Yeah, great question. So the question is, are you going to steal my private keys, basically? So the interesting thing about us is that you have MetaMask, I assume? Yeah, so we just use MetaMask. So you connect your wallet and you sign with MetaMask. So assuming you don't leak your MetaMask keys somehow, then you're good. The bad thing about Hardhat and Foundry, in my opinion, is like you have a private key, your private key, literally in just some .env file in your VS Code or whatever. So that seems like, why are we making that the standard? Why is it that we say, hey, don't share your private key with anyone, but then the way we develop is we just paste our private key in a .env file and like trust that everything is going to work out nicely. So yeah, we don't store your private key anywhere. We just use MetaMask to sign and deploy.